In the last video, I showed you how to velocity depth convert the seismic volume that we're looking at Teapot. Now I'd like to show you how we can take the horizons that have already been turned into surfaces in time and convert those into depth so that they will show as surfaces with the correct relationship to the seismic horizons that we see in the depth converted data. Again, remember the velocity model that I'm using is artificial. I made up the velocities. So in your case, you will be using velocities from the well data that we talked about in class on the spreadsheet. I'm going to use that same velocity model again. And just as I did with the seismic data, I'm going to be able to do a right click on Second Wall Creek, and I will see the similar item domain converted by active velocity model. Now, notice that I have already done this conversion on Dakota, Alcova, Goose Egg, and Tinsley. You will notice that they're now under Dakota, there at the surface. There's now a two-way time version of the surface and a depth version of the surface. That will be created. If we look up at Second Wall Creek, this one has not yet been done. It doesn't have a plus sign out here. I can close that one. So the second Dakota now has a plus sign indicating some choices. This one has not been done. I'm going to go ahead and right click, go to domain convert by active velocity model. Unlike the velocity volume or the seismic volume, this works very quickly. So that now under Second Wall Creek, I have a plus here that I can open. I have two-way time and I have depth. I notice I'm in a mode here, true vertical depth up on this item, and I have turned on the velocity converted depth version of the inline, cross line, and Z. So now I can turn on the depth version of Second Wall Creek. We have to get to where we can see that, so I'm going to turn off this. And I'm not seeing it. Okay. Looks like I have to click it up here first. Sometimes the order of things mystify me in Petrel, but usually it can link through. Now we notice that like many of the other surfaces you did, it comes up in a fixed color. However, we can go in. We'll want to double click the depth item here, go to colors, override the global property template. We'll now have the range of depths for the top of this surface, so we can say OK, and we now have a color representation. You'll see that when we turn on a deeper horizon, I'm going to go down to Tinsley, and it will, I believe, automatically use the depth version when you are in TVD mode up above, whereas if you are in time mode, it will automatically choose that. So we can see the two horizons that are displayed here. And I'm going to turn off the Tinsley, but I'm going to look at, let's look at Dakota, turn off Second Wall Creek, and now we can zoom in and we can see whether or not this depth horizon now still corresponds to the seismic data. So we can see here the interface or the interaction of the surface with the seismic pick on this blue horizon is very consistent, and we could play with moving these seismic sections around a little bit just to confirm that that will work. I'll come in here to the center, go back to the hand, and we can see that the surface does replicate the surface that was originally picked. So that's the way to take, so that we now have both all of our horizons and our seismic reflection volume in depth converted mode, albeit with the wrong velocities, just as an example. Thank you.